Chapter 29, Braking Fundamentals, Video 3, Brake Torque, and Inertia Shift. So a couple things that we need to consider also with the brakes is not only their ability to create the friction, to create the heat, but also the components and how they're attached and anchored to the axles to be able to apply that brake torque into the axle components and suspension and up into the frame and all that. They have to be capable of providing that much braking torque without damaging those components or breaking them. So we need to have the components mounted in such a way that they can affect that braking torque and transfer it back into the truck into the hubs and the tires and out to the pavement. One of the things to consider is during the rapid deceleration that we have to do on a full stop is we're going to have a call it an inertia shift. So that truck driving down the road, the 80,000 pounds, we can't just expect that to stop extremely rapidly. There's still energy in having all that weight from the payload of the truck and tractor it's still moving down the road at the 60 miles an hour. So there's that inertia that is built up in those the payload that needs to be compensated for. And what happens there is that we slow down a rapid stop. That energy is going through those braking components and causes the inertia shift. It's wanting to that the weight and the inertia from those components continues to travel forward even as we are slowing down. Right, so what that's going to do is transfer weight and transfer energy from the rear of the truck to the front of the truck. Those are things we need to consider when we are slowing the truck down and having our brake system to be able to do that. A couple of the potential problems we would have. So on our tire, we're transferring that brake torque through the hubs to the wheel to the tire, then out to the pavement. Well, if our tire does not have adequate traction and we exceed the traction forces that those tires has with the braking effort, that tire is going to slide or lock up. So those are things we need to consider. We've got multiple drive tires on the axles, super singles, that sort of thing, to provide that traction that we need on the connection to the road. If we have too much braking force, again, our tires could slide. We get that inertia shift, and now we're transferring that weight to the front of the truck. We could cause jackknifing where we've removed the weight from the rear axles, so they're no longer able to provide the braking forces. We've transferred that to the front axle, and now it's going to slide, so we can have a jackknifing situation where the load would cause the tractor to come around and lose control. And then likewise, too much on the rear axles cause the trailer to slide out or to swing out also.